Back in the 1970s and 80s, we found that there was an ozone depletion in the stratosphere. It was eventually figured out to have been caused by the introduction of manufactured CFCs that would eventually make its way up into the stratosphere and destroy the ozone. Ozone is very important. It is our sunscreen for this planet. So the Montreal protocols were put in place because we really need that stratospheric ozone to be maintained. So what SAGE-3 is doing is it's measuring and recording the vertical profile of ozone to verify that the Montreal Protocol was successful and that hopefully we're seeing a change, an increase in the stratospheric ozone. Chlorine, the chlorine molecule itself, is a very long-lived molecule. It takes a long time for it to be washed out of the stratosphere. As long as there's that free chlorine up there, it will constantly destroy the ozone. So it takes about 80 years for chlorine to be removed from the stratosphere. So we're halfway there. We're 40 years in. At this point, you would hope to see an inflection in the curve of ozone depletion.
We have some expectation that maybe we might be able to really start to see recovery within the next 10 years. But it's going to take decades after that for it to recover everywhere. And so we've started thinking about SAGE-4. Technology has changed. Here is actually a very simple 3D printout model of what we're thinking about for SAGE-4. We've been able to move towards making the same quality measurements that SAGE-3 makes, but in something that's in a CubeSat, in something that's about the size of a shoebox. And what this lets us do is not only can we still make great measurements, but it also lets us really reduce the cost of these missions. When you cut down on the cost, you open up the opportunity for making multiple copies and then launch them as you need them to continue the measurements. Another good thing is that because they're less expensive, you can actually launch more than one at a time. SAGE-3 makes 2 measurements per orbit, and that gives us a lot of data that we need, but we'd like a little bit more to get a much more complete picture of the Earth's ozone layer on a regular basis. And so launching about 3 or 4 of these at a time would kind of be ideal. And so you can make a small CubeSat constellation, again, for this reduced cost.